also lead the Wargames initiative for the Security Alliance. I'll give a brief introduction to just what the Security Alliance is and what the various initiatives are, because I think it's actually pretty relevant also after the first talk about ENS and data sharing. And so the top initiative here is actually called the SEAL ISAC, which is not me, I'm SEAL Isaac. This is the Information Security something something, which basically this is like a shared database between many different companies where they can share data on like DPRK threat actors or phishing data or bad domains. There's SEAL Wargames, which is the initiative that I lead, where we prepare protocol teams for incident response through both tabletop simulations and then live simulations on forked environments. SEAL also operates SEAL 911, the emergency hotline, if your protocol is under attack or if you have discovered a vulnerability in a protocol and need to get in touch with a security expert as fast as possible. The Safe Harbor Agreement, which is legal protection if you're a white hat hacker and you're acting benevolently in an urgent situation to rescue funds from a protocol. Think Nomad bridge hack a few years ago if you were trying to save money, but maybe you were worried because you thought that you'd be sued for hacking during, because it'd be impossible to distinguish. The White Hat Safe Harbor Agreement exists to protect white hat hackers in those situations, and a legal defense fund in case they sue you anyway. So today what we'll talk about primarily is Wargames. So what are these Wargames and why do we do them? I'll have some links to resources on how you can work with us. There's a lot of open source toolkits, and we also run these as like a public good throughout the space. We'll be talking through some best practices that I've learned from working with some of the major protocols in the ecosystem, and then just briefly show you what this new toolkit is that we released so you can run these yourself if you would like. So what are Wargames? These are cybersecurity exercises for Web3. I've heard traditional cybersecurity folks call these something like a purple team exercise, where we're not exactly red team, blue team, but we're basically just trying to stress test these teams and understand how they behave under pressure. And so we want to help teams practice for these high pressure situations before they actually happen. We want to be able to like test both the technical side of their team and their social resilience. And we're not just trying to help like cause them to panic, but we want them to practice emergency response. A lot of the reason why we started doing this was a few years ago. So the Security Alliance was started by Sam Sun, and he was pulled into so many war rooms where it seemed from what I've heard, teams just completely melting down and not really being exactly prepared for what would happen. So what could we actually do to help put them in that situation before that inevitably happens? So Wargames take place through 3 phases. I do a lot of intelligence gathering, which really just means reading every document that the protocol's ever published, understand their contracts, understand how it works. We do a tabletop exercise where we talk through various scenarios with them and understand how they would have detected them, what they would do, who's in charge, and how would they have fixed something. And then what I think is the most fun is we do a live simulation. So we set up a forked environment, we run all of their contracts, we run all of their UIs, we run all of their monitoring, and then they actually have to coordinate in real time to defend and respond as if it was a real incident. And we tend to find a lot of things that they can improve through that process, and it also just helps the team build trust in each other so that they know when an incident goes down for real, I can trust my team to be there. So a big reason why we do this is because more and more hacks are due to operational failures, not smart contract bugs. That's a really, I think, good sign that we're making fewer and fewer dumb mistakes on the smart contract side. However, as all of the stuff that we're building is becoming such a critical component of global financial infrastructure, the stakes are higher to actually operationally be strong as well. And so whether that's things like supply chain attacks or social engineering, it's much harder now than just like not including dumb bugs in your smart contracts. So these are cross-functional exercises. We're not just working with the development team. They're of course a core part of it, but we're also tending to work with their auditors. If they're a big protocol that has a guardian multisig that's in charge of pausing the protocol in case of emergency, we of course work with them. Communications team is actually essential so that we know like what would they be communicating out to the public and when during an incident, and legal so that they can say, okay, if we were to take this action perhaps to protect the users of our protocol, can we do that? Should we do that? And what should we be saying? the conversations between communications, legal, and devs should really be things that are figured out in advance so that during the incident you're not thinking like, do we tweet out that we're under attack right now, or do we say something cryptic, or what do we say? Like, these are things that you can just have in a playbook so that you don't have to think about it in the moment. We've worked with a number of protocols so far, but the purpose of this slide is also just to show you like why teams are working with us. It's because like teams are growing. These are global teams, and like it's really hard to like prepare for this type of thing. There's many ways to engage with us. If you're a protocol that wants to work with a security alliance and have a drill performed with you, you can. There's a form on the website, and there's also open source resources for you to be able to run these yourself. So this is a quote that I had a really hard time attributing. The internet said it was either like a Greek poet or the Navy SEALs, but I think that it really like stands to show like why we do this, and it's that under pressure we don't rise to the occasion, we sink to our level of training. Yeah, I think that speaks to why we do this. So each one of these builds is quite different. A lot of protocols have like various sorts of like custom infrastructure and monitoring. So every time we do this, we end up having to like build a lot of things. And we've tried to combine all of those tools and things that we've learned on how to run these simulations into this drill template that you can see here. It's on the Security Alliance GitHub repository. But what are the things that we do to make the environment feel realistic? So we of course have to run a network fork. We're usually either doing that with Anvil or with Tenderly. We have to run a block explorer, so we're either running Block Scout or using a virtual testnet. We're running monitoring, so it's essential to mirror the same monitoring that you would have on mainnet. So if you're using a product like Hypernative, Hexagate, or Forta, we should be setting all of that same stuff up against our forked environment. We write bots to behave like users, so if it's a lending protocol, we have a lot of noisy transactions of users depositing, borrowing, lending, swapping, doing everything that would exist on mainnet, so that so it's not like the team only sees like 2 transactions and they're an exploit and then it's too easy. We try to make it a little bit harder. We have an exploit bot which ramps up intensity over time, and then if there's any sort of miscellaneous things that they need to pull in, we try to provide that as well. So this takes us usually a couple weeks to build for each protocol, but we're trying to get faster and faster each time, and part of that is thanks to this open source template that we're working on. So what are some of the scenarios that we've worked on? So as you've seen, we've worked with various like lending protocols and decentralized exchanges and L2s, and so the things that we like try to simulate are not necessarily like bugs, as in like a smart contract bug, because we're not auditors. We're not trying to just find like a mistake in your code. And in fact, like if we do, that's not what that would not be the goal. We're trying to figure out what are the things that can happen if the protocol works even how you designed it. So what if some sort of external dependency fails? What if the way that you're importing Oracle data is weird? Or what if like some token contract gets upgraded and starts behaving differently? So what are the things that are outside of your protocol's control that can change? What if your upgrade goes poorly? How would you detect that? What if there's something strange happening with oracles? And also, one thing that I think was actually pretty fun is in some cases we did like a malicious governance proposal CTF with some protocols where we just like kind of flooded them with a bunch of governance proposals that looked like normal funding requests for events or sponsorships or just parameter updates, but some of them also included like malicious data, like how Tornado got hacked, or I think a number of protocols how they got hacked just by having like sneaky additional call data that ended up having bad implications. I've pulled out a few best practices of what I've learned from working with these teams that I just want to go over briefly. And so one is just maintaining multiple communication channels to reach your teams. One thing I like to tell teams is like imagine like during a tabletop, like imagine this scenario happens, but now imagine that this happened and Telegram is down on the same day that this happened. Can you actually reach the Guardians? Do you have another way to reach them? Can you reach them on Slack, Discord? Can you page them? Sometimes we find that like when we work with a team, like a paging system that they think is set up is just deprecated and hasn't been working in a while, and they can't actually reach the teams that they want to, or they reach the team and they don't have their ledger with them. And so like, okay, cool, we got in touch with you, but you can't actually sign the pause transaction because you're camping. Like, these are things that you want to test. Also, risk isolation. This is we learned a lot, I think, from from how the Yearn team prepares and isolates risk between the different strategies. And so there's a big lesson in like minimizing the amount of contagion that can spread from like one strategy to another, and also the diligence process before any strategy was employed. There was always an emergency response of like, with this change, these are the things that can go wrong, and these are the steps you would take to recover funds before they become unrecoverable. So like risk isolation with Yearn, similarly the asset risk isolation with Aave we found was very interesting, how you can see how there's all these different configuration flags based on how potentially risky a different collateral asset is. They have different properties as far as how they can be used in the protocol. So I think that these are all really interesting lessons from different like larger DeFi protocols about like how you minimize potential contagion and things from spreading. Finally, additionally, incident postmortems are really important. So this is another call out to like the Yearn GitHub repository, where you can see that every time there's been something that has happened, you can see what the team did, how they found out, and then also how they'll be improving in the future to avoid that sort of issue. And monitoring, mirroring monitoring, I think is quite important. Like a lot of teams only will run like their critical monitoring against their mainnet smart contracts. And that's handy, but the things that are actually going to trigger to maybe like pause your smart contract in the event of emergency, maybe it will never happen, or maybe it will happen like once a year. And so how can you really be sure that it's going to be there the moment of? And a lot of these tools are great, and I'm sure that they have some internal simulation capabilities, but if you can also run your monitoring against these like simulated networks so that you can make sure that it's all functioning the way that you think it's functioning, I think that's pretty key. So in the final few minutes, before I'll leave a few minutes, we'll have a few minutes for questions. I just wanted to show you the open source repository that I released a couple weeks ago with all the tools that I use to run these for protocols. So it includes like a Foundry and hard hat setup for like validating different like Wargame scenarios on a local fork. It contains a bunch of configuration scripts for setting up virtual test nets with block explorers to run these, templates for the tabletop exercise, monitoring and bot services, which we forked from an Optimism repository, and also like a stack for setting up like a Prometheus Grafana instance. So like this is all that I use when I run a war game. So this should be all that you would need to potentially use if you want to run one of these with your own protocols. So this is just a brief look at like what the tabletop script looks like. And so we'll be on a call usually, it's like an hour and a half with like the whole protocol team, or with like, if it's a very large protocol, maybe it's a subset of the protocol, a subset of the team, but always cross-functional. And we just talk through, like in this exercise, we're going to discuss various scenarios that you'll need to detect and respond to issues. What we want to like understand is typically like, do you know what the key dependency of your protocol is, and you know what would happen if it fails? Is there sufficient monitoring and infra to detect and respond to these failures? Do you understand who has admin capabilities within your protocol? Are there backups in place? So this is almost an additional information gathering step for us, so that we can design the best live scenario. And then the questions that we ask in each one of these scenarios is always, like, how did you discover this issue? So if we're looking at maybe an L2 and somebody submits some sort of fraudulent withdrawal proof, how did you find out? Did you wait until somebody reached out on Twitter or Discord and said, hey, it looks like X L2 is under attack right now? Or did you have some internal system that would have alerted you within seconds? And so first, how did you find out? Do you know who to gather? Does somebody become an incident commander here? Do you have like an on-call team, or is it like whichever engineer's awake somewhere in the world is the one that has to deal with this? Like, how does that work? Do you have a response plan for this? If not, why not? Is it just too rare? And then who took action and how? And so all of these questions are how we can understand like how well positioned a protocol is to respond. And then for the live drill, the setup steps, this is always the part that takes me the longest, but we create the fork, run the bots, brief the team. I'll send them some sort of like dramatic message of like, you're now in a very realistic simulation where this really bad thing's about to happen. You have to treat it as if like everything was as if it's all real life. But you typically don't need to encourage that. Like they'll go into stressful mode, and everybody wants to show that their internal tooling really works really well. And so yeah, teams we've found always take it very seriously. I always love to observe kind of especially just the conversations between like dev and comms, where it's like communications prepares like a statement, and developers are like, no, we can't say that at all, or developers want to say we're pausing the protocol, and communications is like, no, we can't say that. Like, so that's always really interesting to observe how that works. We have. This is just a view of like a Tenderly virtual testnet. So I found that this is like, I used to set up like an Anvil fork and a Block Scout drop and a Block Scout Explorer, but that would always take me like 2 days. So lately I've been using these tools, but you can run these forks using any tools. But this is like what it looks like when I set up a fork of mainnet. And then this is like my Grafana setup, where I'll have like just a basic invariant monitoring thing where we're checking for certain conditions, like more tokens were withdrawn from an escrow contract than were actually locked up for a user, and why would that happen, and how would we fix it? And then the team actually has to submit the transactions on the testnet. We try to do a couple things to keep safe, like change the chain ID of the testnet so that the actual like response transactions couldn't actually be replayed on mainnet, because we wouldn't want to be able to like take a pause transaction from our testnet and then actually pause a major protocol on mainnet. And so we changed the chain ID. And then we also try not to make them access like keys for safes and stuff if they really don't need to. And so we'll kind of spoof the process of doing like a multi-sig transaction, just in case like there's all sorts of security procedures around accessing these keys. Yeah, so we try to keep teams safe doing that. Here's a link to a few resources. The first one is actually related to an event that was 2 days ago that we hosted here in Bangkok, but I left it there because I think we'll be doing more of these like live events where you can compete with each other to try to white hat rescue funds from protocols. The second is the GitHub repository. We have the Security Alliance website where you can sign up for a drill sponsored by the Security Alliance, and you can also sign up for drills on my company's website, Shield3, if you're on an accelerated timeline. Or feel free to chat with me if you're just like, hey, I want to run Wargames for protocols. I'm happy to share. So thank you.
All right, thank you very much, Isaac. Appreciate it. Even though we started late, you finished well within your time. I really appreciate that. And I'm happy to say that our questions are now working. So let's turn our attention to the screen. I'm going to read out the first question with the most votes. Is it possible to have a SEAL team member be part of a protocol guardian's multi-sig somehow? Yep.
Yeah, a lot of us are on some of these multi-sigs or on security councils. We actually talked about this recently, like if SEAL itself should be like members of security councils. We came to the conclusion, I mean, this might change in the future, that like us individually can also be like on security councils, but SEAL itself is not. But like many SEAL members are open to being like on these on Guardian multi-sigs and stuff like that. So just find me and we can help.
All right, thanks for the answer. Thanks for the question. Next question that got voted to the top. Do you share threat intelligence data on chain? If no, how or where do you share threat intelligence data?
Yes, so the Security Alliance website should have a link to the SEAL-ISAC, which is the information sharing tool. There's a large amount of data that actually is available publicly, but then also if you're like a wallet company or an exchange, we're also, there's like even more sensitive data that can be shared in a more private way. So that's the best place to look for like for just data being shared across teams. It can be, they're even starting to gather a lot of information just about every time like a North Korean developer applies to a protocol, they try to just like profile it and understand like how they're doing it, who's getting in, just so that we can like share data on like how teams are being like trying to be infiltrated. So
Thanks for the answer.
SEAL-ISAC. Yeah.
Thanks for the answer. Great. All right, let's go on. We've got time for more questions. Does the drill occur unexpectedly, i.e. the team knows it'll be happening, but doesn't know when?
I've gone back and forth on this a few times. Initially, it was like we would give them an 8-hour window and then say like, okay, it's going to happen at some point in this 8-hour window. But then I was just sitting there like stressed waiting for it to start. So I always just started it right at the beginning of the window. So I don't know if like, it might be fun to do that. I think at some point we're thinking about like, can we do like more surprise drills on these longer running test nets where we like submit a faulty, or we submit like a faulty proof to like an L2 rollup or something like that, just out of nowhere, just to surprise a team. But yeah, typically they know that it's going to happen on a certain date, but it still maintains a pretty good amount of realism.
Right, thank you very much. Surprise, you've been compromised. Anyway, let's move on to the next question. I think this is an important question. It's got quite a few votes as well. What's the most common way teams fall over?
I think one of the most common things is like having your internal tooling just not be up to date. So it's very like maybe like one developer was very inspired a year ago to make all of like these really great internal tools, but then like the protocols changed a bit over the last year and the internal tools don't work. So I think like maintaining the internal tooling that you need for these scenarios is very important, and dedicating engineering resources to doing that so that like it's not like, oh, I really hope this tool works when you're actually in the incident.
Excellent answer. Fantastic. We got a little bit more time. Let's try and do one or two more. Any way to react to layer 1 protocol incidents?
Yes. So I think that we're thinking about some fun things to do on the layer 1, like maybe related to like major like L1 protocol upgrades, thinking about what could happen if there's major chain splits or forks or bugs in a certain consensus client but not another one. Like what chaos could we simulate across the whole ecosystem if upgrades perhaps go really poorly, or if there's bugs or supply chain attacks into major like validator code. Of course, like these are things that shouldn't and probably won't ever happen, but it's fun to practice, and I think worthwhile to practice the response.
Excellent. Isaac, you got 1 minute for the last question. Do you go through the worst case scenarios in Wargames? For example, you got hacked, money is lost, what now? Do you go through contact with law enforcement?
Typically, actually that's a really good question, which I didn't touch on, which is like, we try not to just make these like an instant wrecked scenario, because it's no fun if we just say, protocol was upgraded, there's a bug, all the money's lost, you can't do anything. Like that's no fun for anybody. So we try to make it something that's like recoverable, that they could actually respond to. But I think, yeah, actually on the last one, where we had like some money stolen, they were like, okay, now how would we actually try to like chase down this money that we got that was stolen? And the answer is like that's something you can go to SEAL 911 for, because they have really good like tracing people that can like say, okay, now we're going to see where the money's gone and try to recover it in other ways. And so yeah, if you get hacked, first fix the protocol, but then yeah, we can also help you track down the money.
Excellent. Wow, we finished all the questions in record time. Let's give Isaac a big round of applause. Well done. Thank you so much, Isaac.